Example 5, if a baseball is thrown at an initial speed of 15 meters per second from a height of 2 meters above the ground, the inequality given here models the time t in seconds that the baseball is in flight. During what time interval is the baseball in flight? So basically here, this information is already incorporated into this equation, or inequality rather. But I'm going to help you visualize this. So basically 2 meters, so this would be height over here in meters, and this would be time in seconds. So it started at a height of 2 meters, so that's probably where they were throwing it upwards. And a ball, of course, is going to go up in the air and back down. Now, I don't want an arrowhead here because this isn't going to continue through the ground. So my goal is to figure out what time interval is the baseball in flight. So I want to know from 0 to what time this is. So I'm really solving for this inequality here. So you want to find the intercepts, so t-intercepts here. So we're going to find t-intercept, which is like thinking of the x-intercept. So we're going to use our quadratic formula. I don't want to try and factor that one. So negative b plus or minus the square root of b squared minus 4ac over 2a. So you're going to plug in negative, and we have 15 plus or minus b squared, so negative 4.9 squared minus 4 times negative 4.9 times 2, extend that, so that's all under the radical, 2 times negative 4.9. Now you're going to use your calculators to square this. Two negatives you'll end up adding. It would not make sense to have a negative number under there, so you would know, you would catch that. So you can pause if you need to go grab your calculators and put that in, and then check to see what you should get. So under the radical, you get 264.2 divided by negative 9.8. So now we're going to determine what both of those values are. So you've got two t values. So t is going to equal, and again, this is putting in your calculator, negative 15 plus this radical divided by negative 9.8. Then you're going to plug in negative 15 minus the radical divided by negative 9.8. So when you do that, and again, you can pause the video to do that, then check your answers. You're going to get negative 0.1279, and you're going to get t is equal to 3.1892. So it does not make sense to have a negative time. What's really happened is, and it makes sense, I'm just going to extend this. This wouldn't want to be part of my answer. It makes sense that this would go a little bit further, and it would cross at approximately negative 0. In fact, I'll maybe make a note of that. That's near negative 0.13. So that makes sense that this negative number, but we're not going to use that in our solution set. And then this intercept right here, I've got my labeling on the way here, so I'm going to have to write below it 3.1892 seconds would be this x-intercept right here. So now my answer is an inequality because it says what duration or time interval is the baseball in flight. So we're going to write our proper solution set here as an inequality. So the variable we're talking about is t. So we say t such that. Now typically my answer would be between negative 0.13, but we can't include that. So we jump to 0. The initial time would have to be 0. So 0 is less than t is less than 3.19. Where it's still real numbers, you can have your decimal answers in here. So it's very important that you have that solution set. Now, because this is a word problem, we want to write a sentence that discusses the inequality. We don't want to just say it's in flight for 3.19 seconds. That's more if it's just solving for the t value, even though that's a true statement. If it says the time interval, you want to use the word between. You want to say a between statement. So the ball is in flight between 0 seconds and 3.19 seconds. So we're looking for something like that. So I underlined between. So when you've got your inequality signs, if you've got a word problem like this, that you have your solution set and your sentence that includes the entire interval.